demand this infrastructure, in line with which this infrastructure require communication. The communication nothing but it can be a wide area network composed of PSTN, public switch telephone networking, radio communication, microwave, cellular, satellite, anything of such, which will get connected to the areas like a generating area or a load center or any transmission grid like that, where we will be having RTU, remote terminal unit, which I am pointing here with a mouse cursor. This is the area like 1, 2, 3, area we call as RTU, remote terminal unit, which is composed of a PLC, a computer, computing facilities, which will collect all the necessary information for the processing to be taken at the energy control center from the perspective of that locality, maybe generating station, maybe a load center, etc. That information after being encoded is telemetered to the energy control center. So these transmission representation lines are nothing but communication sections. Likewise, area 1, area 2, area 3, which are connected by an RTU. Remote terminal unit is a specific unit looking after certain functions only. It is defined for a generating area. It is responsible to communicate from that generating area to the master terminal unit, which is another interface at the outlet or at the particular energy control center to communicate with the RTU. Each MTU, master terminal unit, receives information from number of remote terminal units. Like these are the clients, that is a managerial request, we can say. MTU takes information from all number of such RTUs. One MTU can access multiple RTU, but one RTU can do one task, that's all. If it is a generator area configured, its responsibility is only with respect to generator. It is concerned with the load center, only load center related information it has to transmit and get the information from the energy control center. Like it is a bidirectional. Whatever I am speaking is bidirectional. From the energy control center, signals routed to this. From the remote center, signals are taken to the processing in the energy control center. This is how one interaction we have done. Now moving to that, just see another view of which supervisory control and data acquisition system. I have made it something different from the available resources. Whatever the energy control center, one typical computer table I have shown, master slave kind of computer, where a master is a foreground working computer, slave is a background working for planning and as a standby computer like that. Both are active, but one of the computers is compelled as a master during its normal working. On the failure of that, anything goes wrong with that computer, the slave takes the role of main or a server like that. So this computer facility, computing facility getting connected to the communication network, is an exchange. So private exchange, cable, wireless, internet, anything of that, that is connected to the station number 1, station number 2, 3, 4, like that. Substation I have mentioned here, an example. So from this substation, you look into the arrangement of it. The information from this intelligent electronic devices, transducers, which transform the information of one form of signal into electrical form of signal, miscellaneous control equipment, and distributed control system, DCS. This system operates with all these interconnections in that substation to fetch required information and to control them. And this information is encoded and telemetered via the transmission mode to the energy control center. I can tell this dotted box which I have shown is one RTU role. Role of this RTU over here is collect all these information and inform to these devices from the energy control center through the gateway. Like here is a gate which is nothing but RTU. Remote terminal unit is responsible to communicate to this station 1 from the master unit as and when it receives the information, and as and when it requires, it will provide that. That is the task of RTU over here. In turn, RTU, when I magnify, it will have again an infrastructure interconnected inside the plant from the generator perspective, from the load, buses, voltage, current, power, measurement of all such requirement using intelligent electronic devices and transducers as required, which will provide the consolidated information in the format which is readable from the energy control center. Like this, station 1 provides the information. Like 2, 3, 4, N stations are connected to this. This is another view of supervisory control and data acquisition unit. Now when I view next, what exactly is SCADA control? Again, I have taken a similar image and a large control panel, and in which I have so many vectored computer and houses which are interconnected to this box or this panel. What exactly this energy control center does then? Already we have interacted so many functions. It is going to facilitate the operation of power system with the objective with which it is installed. Basically, I can list a few of them. It definitely triggers a tap changer, change the tap, decrease or increase as per the requirement, switching devices, isolation or any line coupling or circuit breaker operation, closing, opening, put in service, remove from the service. Switching devices can be controlled from this, like a shunt capacitor and reactor. If any power factor control, reactive power balance, if it is there in the system, it can be configured such that the particular energy control center SCADA supervisory control and data acquisition mechanism with the proper software and hardware which is interface will be able to provide control action on these end devices like a capacitor to include or to exclude, like a reactor to include or exclude as per the need. And generator set points like that. Suppose you are talking about a generating area interconnected to an energy control center. SCADA relevant to the energy control center, if I view it, what you can do? You can control the excitation of that generator. You can develop required power output from that generator by changing the mechanical set point, mechanical input, or its excitation at the field side. You can maintain the terminal voltages and all. So this is possible from simply from the energy control center SCADA perspective. Now you can visualize this SCADA is somewhere in the energy control center, which is not at all there in the plant. Plant is far away from the energy control center, somewhere else at the geographical position where resource is available. Energy control center need not be at the point of energy or a resource. It can be somewhere else in the corporate office like, which is having an interface interconnection with those things. These actions, what are being initiated at the energy control center, do act on the mechanisms at the generator. So you can control. As well, sequential control. As it is in a single line diagram, we are able to view on the graphical display. We are able to see the touch screen, simulate, touch, operate, open, close. In a sequential manner, I can program them. One after another, line B closed, line B open, messages B sent, inform, record, retrieve. All such possibilities in a sequential order can be processed. So this SCADA is just by having its keyword understood, supervisory control and data acquisition. Basically, it is meant to acquire lot of information of the particular power system required as a in data to be processed. Upon processing, the outcome of that is to initiate control on the power system's operation such that such an operation ensures the fulfillment of the objectives of the power system. In that due regard, it is a infrastructure facilitates the decision-taking authority to decide and execute their duties in an appropriate manner. So therefore, in overall, it is a support structure for the operation of the power system. It has to be done in a systematic manner. Similarly, when I go down the line, how exactly a simple one table in that energy control center I was highlighting in the earlier day, several computers hierarchically positioned and master slave in operation connected to one another and operation is done. Now suppose if I take a single computer table, how is that functions and functionality of that control can be understood. Let us take a energy dispatcher, one table in which I will find two computers, master and slave. How the entire work associated with the dispatcher who is operating the computer is characterized. Now look from this bottom top approach. From the bottommost way, it is a remote terminal unit. It means the field data acquisition and control. Now imagine corporate office is an energy control center like that. The client office is somewhere far away, which is a generating area. From the generating area, what are all the information you would like to say take? From the load center, what are all the information you would like to fetch that is here? Field data acquisition and control. What is that? Status of breakers I would like to know. Switches, phase voltages, real power, reactive power, ampere flows, current flow, transformer tap position, phase shifter, if so, what is the current situation, device temperature, limits of operation, any inequality constraint, min, max, etc. These are all the parameters of a certain locality which is a generating plant, generator's perspective. If it is a load center, load's perspective, all these field information need to be collected and acquired, has to be digitally encoded. It should have a proper mechanism so that nobody should tamper this information. So it should be digitally encoded. That information is passed to the next layer, which is SCADA communication links and database. So I was just giving you an information. At every field, you will have a RTU, remote terminal unit, that is responsible to get the data from the energy control center and disseminate into the field, and from the field obtain the information and transfer it to the energy control center. Like that, RTU, remote terminal unit, was given the responsibility of transacting that at the load side. Once that information is readily processed, and that has to be transmitted, digitally encoded and channelized into different modes of communication, wired mode, wireless mode, or a satellite mode, any of the mechanism with which communication of this information to the center is done. Then it will reach to the master terminal unit. Now I will come to the corporate office. At the corporate office, it is nothing but an energy control center. Number of computers are placed, hierarchically managed, which collect the data from the field. Once I speak of energy control center, from the energy control center perspective, there are so many connections. One from generating area 1, another connection from generating area 2, 3, 4. All the generating areas are connected, all the substations are connected. So each master terminal unit configured at the communication setup of a energy control center gets connected to number of RTUs. Each RTU is one locality, generating locality, a grid, or it is a load center like that. Number of such RTUs are configured to respond to a single MTU, master terminal unit, which collects the information from configured areas, and that is processed and dumped into the memory of the storage. It means to say information from the field is processed and taken via RTU, via the communication mode, through the master terminal unit, after pre-processing stored into the storage. Once it comes to the storage, now I come to the computer of that energy control center. How the functions of that particular computer table is configured into high priority tasks and secondary functions like that. You can see whatever the functionalities that energy control center computer can exercise were discussed in length like alarm indication, voltage, power flow, area control, automatic generation control, estimation of the state, economic dispatch, and pool data exchange among the neighbor. All these things, contingency analysis, load forecasting, and buy and sell with the neighbor corporation, load flow study, commitment, historical data recording, stability study, fault analysis, all these operational aspects of a power system were listed down and were discussed. Now we have to segregate them into priority wise. The most priority is given as high priority functions like indicating alarm. Suppose the system which I am supervising in the energy control center connected to that any alarm, any failure, any probable upcoming tripping failure, if they were sent, it is to alarm those authorities such that such an alarm is an alert indication to keep control action acted such that system is brought back to normal. And status of that should be informed. So the circuit breaker which is likely closed need to be opened due to some decisions which are taken due to fault study, due to any variation. It has to be informed. A transformer tap position, it is neck to neck last point. Further any shift in the position is not possible. It should be indicated. Then bus coupler, isolator, anything of such status has to be very precisely with the priority be communicated. And the measure, the notice of bus voltages is one of the important aspects with the priority. And power flow. Exactly, power system is meant to transfer the power from one bus to the another to the grid. So therefore, this power flow has to be systematically monitored and observed for any undue overflows as well as the overdrawal and tripping, etc. like that. Then area control error. This is a new keyword we have learned or understanding today. Area control error is an error obtained from the generating station. What is the total demand on that station? What is the total generation going on? Minus. Then the area bias. Area bias is for every change in load, how is that frequency decreasing? So that ratio is mentioned as an equation called as area control error. This we will be discussing in the next module with the block diagram, with the relevant explanation as well. For me, area control error is the error of a particular generating station. What is the command? What is the current generation? What is the change due to load variation? That error has to be zero. If error exists means there is a deficit generation noticed on that station. The generator have to coop up that generation and make the error zero. That is the indication on the generator. Area control error means it is one controlled area. One of the generating area is a controlled area to which signal reach, set points are adjusted, generation would take place, and the total delivery, total requirement, total changes contingent has to be controlled into a zero error. If there exists a error, it indicates that generation right now what is going on is a deficit to the requirement, and it has to be worked out to make the error null. In that way, that is an important aspect. If that error is not brought to zero, mismatch between P, mismatch between Q indicate that there is a frequency oscillations and the reactive power imbalance due to voltage, or voltage imbalance, voltage instability due to reactive power can be a situation. To address that, error shall be under the control to requirement. So that is the one of the important stimuli for the automatic generation control. What is automatic generation control? It is a computer control of generation from a generating area to see to it that net transaction is always met, addressing all the adverse things which are really occurring. In that due regard, automatic generation control is a computer-based control of generation and delivery and dispatch of the power. While doing this system requires stimuli. That is the area control error. If the area control error of a locality is zero, No further change in the command. What the command is simulated, that command should continue. If the error is increasing, demand is increasing, error is increasing, then error has to be nullified. To nullify that, generations have to increase accordingly. For that way, automatic closed loop is simulated for this automatic generation control. That is a priority aspect because power system has to address P balance, Q balance at every moment of its operation. State estimation. As we were interacting in the earlier interactions also, state estimation is a scientific evaluation of a state variable to see to that the probable changes what would occur, what will be the state of the power system during that situation has to be estimated with the minimal set of function keyword called as state variable. It is an evaluation of the state of the particular power system. It is very necessary every moment. It should be run as a separate algorithm. This will help to assess the securedness of the system. It will quantify the system's reliability. If this state estimation is not properly done, not at all there, how would you feel the next state of operation is secured, safer, reliable, cost effective, profitable to the corporation? Because being in the engineering role, all these engineering functions has to be there to see to it that suitable operation control is exercised, to see to it that system is always put in proper practice. Then economic dispatch is one of the important aspects which I was highlighting again and again, because here comes economy of the generation, resource, and all such non-material resources are involved in making this power system or making the power system to be in the market profitable. Economic concern to the activities what it endeavors has to be systematically planned. Then it is a priority based function. It should be given higher priority, should be performed well. Power pool data exchange. This comes into picture when I have a generating setup. My generation, which right now I have established, may be suitable for the current plant demand. As the plant demand increases due to load growth, due to industries upcoming and civilization is going on, any neighbor corporation is demanding more and more power from my plant, definitely power pool data exchange. It means it is called pooling, grouping into different sections. My group is connected to the neighbor group is connected to the another group, and we were agreed upon exchanging our power as and when we are in excess generation to meet their requirement and make ourselves profitable among each other. When we do it, definitely what is that I have exchanged? Why do I do this? Who is exchanging with whom? All these powerful data is required to me. I can tell one important fact. Imagine it is between three districts. District number 1, down the line, district number 2, down the line, district number 3. From the district number top to down, third one, there is a power flow happening. And it is happening through the central district via transmission line. If the transaction between 1 and 3, district number 1 and 3 is going through the district 2's transmission section, why the district 2 should be informed? It is to be informed because power flow is affecting the district number 2 also. Even though it is healthy, due to the fault at the district number 3 or district number 1, which are interconnected, their fault gets propagated into the district number 2 because of interconnected operation. When all become in parallel, definitely cumulative effects will be there in the system. Hence, it is always a priority task to see to it that who is exchanging with whom, to which I am a part of the system. Because of their adverse control, because of their profitable mode, I may be disturbed. In that is an important parameter with the priority. Some of the functions put with a secondary function, like a priority lesser than what it is. It is a contingency analysis in the background mode. Continuously it is done. And load forecasting, it should be done. It need not be the main activity. It is a background activity, continuously it is done. It has to check what is the growth of load on my station at every moment of time, every weekly, fortnight, monthly, bi-monthly, quarterly, as required for the corporation's growth considered. it must invest in tools and sets to estimate the particular requirement in the forecasting mode and buy and sell negotiation. See, when I am doing the main transaction at sitting at the main computer, I cannot do buy and sell activity because my main focus is on energy system operation and control, automatic generation, estimation like that. So this kind of activity is done by some other officer in the second computer or in the computer running in a secondary loop automatically. What is the buying, what is the selling? So these functions are secondary. Then the continuous study of power flow, which is the backbone of power system operation, which should be done in the secondary computer continuously. It provides the P, Q, V, delta data periodically to make my control action on the other side. And unit commitment is an important aspect that we were defining continuously. I should see to it that the committed units are really delivering me the power or not. If they are not doing, which is the next best unit I must combine. If the one which is to be eliminated from the schedule, which is that I have to eliminate, this kind of commitment schedule has to be systematically viewed in the background. And historical data logging. This is nothing but a data acquisition mechanism. Whatever has happened with the timestamp of start of the computer, next one, next one, next one, all these events are stored in the computer in the form of data logged and stored for the future use. That is called historical data logging, which is the one strong proof that SCADA is very useful because it has a lot of data already stored from the previous years and operation facts, which will serve as a backbone for the training purpose, research purpose, future planning and expansion point of view in that regard. Stability aspect. This is one of the important aspects. Stability of a system is an ability to be in practice even after encountering any disaster and effect of adverse things on the system. So this has to be studied very systematically, and outcome of this has to be put as a notice to see to it that as and when I am trading power, as and when I am controlling the generation, is my stability is challenged by my action or not? Do my actions right now set point change in generation, decrease, rejection, whatever I am trying to do, is it safe with respect to stability perspective of the power system or not? This has to be viewed appropriately. And short circuit settings. So this is another fault study. There are typical faults what really occur on a real power system due to so many switching events, due to natural or internal failure, external failure, due to calamities, anything. Faults are very natural. Due to the occurrences of those faults, criticality of a certain fault or a location has to be found out. Countermeasures to act on such a situation has to be kept as a remedial for the energy dispatcher to see to it such an event as and when it is noticed. So the seriousness of that control action has to be initiated to see that system is under your control. For that, this is another specific study being performed and kept in the secondary function continuous is being done in the background. So this is how a computer table in the energy control center, when I view as an operator performing so many tasks on that computer, be connected in this mode. From the field, fetch, process, store, one end. From the energy control center perspective, lot of these information being processed by computing algorithms, process, update and retrieve, control and again save. And those signals will come down to the field again. This is a bidirectional mode of exchange of information from RTU to MTU in the energy control center. This is how I wanted to present to you functions and computer configuration of energy control center. There can be one good question for you. What are the configuration? What is the configuration of the computer and energy control center? It is a master-slave computer. Master is the one which is online computer, which performs so many high priority tasks. Slave is the one which is acting as a background computer which performs certain functions which are useful for the main function to be taken into consideration. It provides output for the priority function to take decision based on the outcomes of that. For that, the fetching up of information is from the field. How the field communication, RTU, MTU come into picture has to be connected. So very high-end processor with an enormous computing facility, huge memory should be put in the computer. Lot of displays and communication keyboards and function keyboards must be there. This could be a one outline which demands the computers which are used for the energy control center are not the ordinary computers. They are the high-end computing computers with the installed package, which is energy management software. Then how exactly a power system operation be viewed with respect to computing facility and monitoring and other time scale, etc. Now this is just a view. A system-wide monitoring is possible. When I use a power system SCADA, system-wide monitoring is possible. It facilitates us to plan for the future, optimize the existing system for reliability concern, cost-effective mode of operation is considered. It really helps because you are able to visualize the entire power system on your screen. It becomes very easy for us to see what part of the system is highly dominant, dense in workload, loosely connected, chances are there to get faulty or get failed, and which is having a potential to improve upon. All these things I can visualize. I can see from seconds to hours of scale, continuously I can see the system and connected to one-to-one interconnection. So I can view this interconnection of the energy control center computer with a remote field area by various kind of communication network to the various area, RTU1, RTU2 area, substation, having communication connected to this, and is having a lot of background computing facility storage and all. This functionality can be viewed from this transition mechanism. When a system is normal, all the computing facilities declare you everything is under your control. Parameter what you are observing is well within the range and things are going well with the transaction. When any of the computer or any of the device in the field suffer or a mechanism suffer a minor shift in parameter, it's an alert that is indicated in the computing facility over here as well as in the energy control center. I can supervise it that the system is entering to an alert which I am observing, not the entire perspective, a section which I am trying to view on my screen for my specific mode of observation. Is it safe? Yes, normal. Is it really going under the alert? Yes, there is a minor change in the operational aspect of the transformer or a generator, transmission mechanism. I can just see whether the alert. Any control action not being initiated locally, I can initiate from the remote. If not taken, it has entered to emergency. I am able to monitor the parameters. I am not observing the controller here. I am not observing any person over here. I am observing the field devices. Field devices are my elements which provide information to my view over here, wherein remotely I can monitor and I can control if necessary. So that state of power system can be either in emergency or in alert or restorative. I can visualize sitting in energy control center. This is a facility and what I can say scope, system-wide monitoring is possible. I can monitor only selected view. I can monitor the entire plan of the power system like that. That is possible. When that is possible, an effective operation is highly possible. When I use the effective operation, I can make it cost effective, make it to more reliable and bring any technical optimization, which will definitely reduce the usage of non-material resources to make the maximization of the performance. And I can even plan and execute future expansions if so, any modernization to be brought into, I can definitely be planned. Unless I view it really repeatedly to see its reflection, I cannot think of that. When there is a defectiveness repeatedly occurring on that, faults repeatedly occurring on that, I put light on that. Why do this occur repeatedly? What is the root cause for that? How to eliminate it? How to modernize it? I will look. That is the test is done. system-wide monitoring, if I get, I am able to understand the defectiveness, frequent failure or monitoring, how my security is challenged in that perspective. So, from the system operational perspective, supervisory control data access system facilitate the energy dispatcher in a very specific way. How is that components of SCADA be identified? Let us go one deep down. I was speaking about in every end device, a master terminal unit, which is at the energy control center, get interface to remote terminal unit, which is a field device, which may be a PLC, an electronic stack, which the image shows you, which is electronic component, programmable component, which is installed in the remote. So, a remote terminal unit, RTU, is a microprocessor, controlled electronic devices that interfaces objects in the physical world to a distributed control system or a SCADA to get the information and to transmit it to the energy control center by for the supervisory control and mechanism. Let us come to the reality. What is exactly this device is? This is a device to be installed in the energy generating plant or in a load center or in a transmission mechanism which I want to monitor, control and get communicated to the energy control center. This is an interface. Example, if I connect it to a generating plant, I call it as a RTU connected to generating plant. When I install this electronic component, as it is a microprocessor base, I can say computer base, which is interfaced with lot of electronic intelligent device, which may be connected to a CT, which may be connected to a potential transformer, which may be connected to a status indicator of isolator, bus, coupler, circuit breaker, transformer, generator, RPM and other, and the controlling mechanisms at governor side, etc. Whatever is the field I have at the generator's perspective, all those parameters which I want to connect to the energy control center, transmit them, status of them if I want to transmit to the energy control center, this electronic mechanism is an interface. It collectively takes all that data and it will make it coupled and communicate it to the remote center, means energy control center. This is an electronic interface. Having, you can see, this is a CPU, electronic card 1, card 2. These are just like a book rack. It is, they are plugged out and pushed in. Those who all of you have already seen on ELDC, area load dispatch center in Navanagar or any other area where you got an opportunity to study and view, such an RTU you will find, such an controller you will find. In a cabin it is installed. It is a controlled environment for being electronic. Then having communication mechanisms, having electronic devices interface to that. That electronic device which is a field device, which the normally open contact, normally close contact, NONC, what we call as, and a variable transducer output or analog signals or a field open close command. All those information from the field are connected to these IOs, input outputs of this electronic rack. That is compiled, that is communicated to the master terminal unit which is there in the energy control center. It is just like a communication bridge from the generating area to decision taking area at the energy control center. So we call it as RTU, remote terminal unit. It can be a PLC also. This is one of the Allen ABB made. This is one of the best component in the world. These people are manufacturing the components and serving the community in the power sector by installing all such automation devices in the road. So this ABB is one example. Image is shown, is capable of collecting lot of information connected to the field. It is not barely connecting or collecting the data. It is again connected to intelligent electronic devices which are in between the real field component and the RTU. It comes IED or MFD, multi-function unit. Those electronic devices are really connected to field. That field information is digitized and communicated to this RTU. RTU in turn compile all those and transmit it to the remote to master center. So likewise this one. Then how the communication will take place? The communication is one of the very critical need. Even though I have a power system with set-off generator, load, transmission mechanism perfectly installed to the capacity fullest possible, this particular discussion what I am doing, an energy control center operation from RTU to MTU to the energy is a communication I am speaking. Signal from end device to the center, center to the end device I am trying to speak. For this to act in reality, communication is very necessary. Communication which may be a wide area network. Lot of communication patterns, protocols, modes of interconnection need to be discussed here. For that, wide area network, a large geographical area is considered. Analog point to point means it is a contact one server master play master like that, point to point communication. Point multi-point modem network. It may be multiple components communicating to single. I have diagrams next to the slide. So point to point, point to multi-point, multi-point to multi-point. So many such modes of communication are there in the mechanism. Frame relay, cell relay type point to point and multi-point network. So these are the keywords coming under network terminology. So communication network terminology. For us, let us remember we require a communication aspect for my information of a generating plant to be connected to the master center. From the master center to the field device, communication is vital. Everything is correct, but communication is lost. How do you transact? Signaling will go off. So it is like an ATM machine having money, not able to transact because of your lack of security verified or your account detection not being done. How can it dispense the money? The same way, it is equipped with the generation, equipped with the communication, equipped with the transmission grid and all, but communications are not working. Definitely it becomes a very difficult task. Then, once the wide area network is a need, wireless, satellite communication or a fiber optic communication, many more communication networks can be viewed for this. Then how do that connect from one device to another device? Language of communication, which we call it a protocol. With what kind of communication it will understand what the device is trying to convey, what it understood, how it will make the upcoming device to get understood by that data. That's called language of these devices as a protocol. So there are so many protocols identified in the particular mode, the one being Modbus. It is again I will list one by one later. Modicon's development Modbus. Profibus, Professional Field Interface Bus, Profibus. Then IEC, International Electrochemical Conversion, IEC 60870-5-101, maybe 101 or 104. These are the communication standard defined in the international perspective. And Distributed Network Protocol 3. Then IEC 61850-90-2. Then last one, IEC 60870-6, that ICCP between controls and center. What do you mean by this? These are the standards under the protocol one by one. In the incremental mode, these have been developed historically and IEC standards are running now. Presently, in the real world, which I want to tell you the real communication, it is IEC 60870-5, 101 or 104. TCP IP, that kind of communication is working in the communications between device to device. Now you may be wondering why these many banks. I tell you, the manufacturers of intelligent electronic devices for the automation of the substation, once it has begun from the olden days to the current day, people started manufacturing the device, listen to their own communication device. It will communicate only with their own product. Later it becomes difficult because if I have a today's product of one company X, company Y product, I cannot connect to that because it will not connect to it, it will not interface. There is a mismatch between the communication between the language, what it is expecting, the language, what it is communicating. This is how this becomes a mismatch. Then standardization among the components. Manufacturer A of American, manufacturer B of a German, manufacturer B of a Japanese or anything of European. Those corporations, once they set up with their own monopoly. They have developed the algorithm, they have developed the language with which they get connected and respond as like a Modbus, Profibus and different. Later, when you want to connect a component which is intelligent, available in the market public, when you purchase it, it must be capable to listen, communicate with the peer devices which are of other domicile, other type of manufacturer. They must communicate so that exchange of data between them become a challenge. Hence, standardization in the language of their mode of exchange of data has been tremendously worked out, and today we stand with standardization. Whatever I manufacture the component for a certain application, if I sell in the global market, any country which purchase it, it must be capable to work in their working domain without any problem. Then my device understanding and communicating mode and exchanging pattern and data should be common to the standard. That language protocols have been defined ideally like this. Modbus developed initially in the early days of 1960s. Then slowly it has come by 5 to 10 years, decade, Profibus, Speed, Professional Bus. Then IEC made standardization and distributed network protocol 3, like your Bluetooth 2, Bluetooth 3, how I speak about communication wirelessly in this regard. Then IEC standard. When I go down, we'll see individual to this, I have a paragraphic presentation. This is the requirement of wide area with all possible modes of communication, and with all or each communication, there should be a language to communicate, which is the protocol, which we listed down one by one. Next to which is IEC 60870-5, 101 or 104. See why it is developed. What is the need of this? International standards for open transmission of SCADA telemetry and control information. See, there is a need. When I manufacture intelligent devices in Japan, when I use them in Europe, when I use in the Asian continent, definitely there should be a standard to get connected to one another, to display on the screen, to understand, to query it. I should have a proper understanding of that. Then standards have to be open. People will be able to manufacture against that standard their own product, so that each component which is developed is competent to be used in the market. In that due regard, this is an evolution, standardization as an open transmission mechanism for supervisory control and data acquisition for any telemetering, exchange of data and control is to be done. In that due regard, this standardization has come. Like how we have the communication system in cellular now, 3G, 4G. Anybody can manufacture the component adhering the standard generation setup 4G or 3G or 5G. Then my product is capable of having that bandwidth and exchange of information, definitely I will be in the market. Like that, this open transmission protocol standards were identified. This provides detailed functional description for telecontrol equipment and systems for controlling geographically widespread processes and specifically intended for electrical industry. See the thing. There is a scope for this device. Can I use it in a mobile? Can I use it in any computing facilities? Definitely no. This is an exclusive standardization brought for electrical industries. When I have electrical equipments interconnected to one another in a plant, one another in the another plant. I want to make my plant one talk with the another plant two. Interfacing between those two if I want to do. How do my component in plant one are performing? How do my components in plant two are performing? I would like to check. Then interfacing become a challenge for me if they won't be on a common platform. This is how these electrical equipment and industries practice this standard so that their components are able to communicate over a wide range of distance specifically for communication. And in turn, when reference to a certain IEC standard 60870-5 in the context of SCADA, with respect to perspective of supervisory control and data access system, is made it usefully or usually for 101 or 104, titled as companion standard for basic telecontrol, which is nothing but TCP IP. You can see at the bottom, 101 protocol intended for transport of data over serial communication. 60870-5, if it is 101 for serial communication. Serial communication may be point to point, point to multi-point. It is between connected devices only. When 104 is practiced, it is a protocol for transfer control protocol and internet protocol, TCP IP implementation of 101. 101, which is a serial communication. Serial communication is made with a TCP IP flavor, language of understanding, TCP IP, transfer control protocol or internet protocol, which is 104. By implementing these communicating abilities into those electronic devices, that device is common to practice in the energy sector. Now imagine the real power system industry over the country. The communicating devices in Kashmir and in the Madhya Pradesh or in the Kanyakumari or a eastern or a western side. One grid kind of thing if you just connected. Once you see the entire connected grid on your screen, you can compare, you can query the components of particular locality with the particular locality and get the information. How do they respond one to one? They are able to find out the causes and they are able to respond to you. In that way, there must be a common element when I replace it, when I install it. I must be able to get all the information. It is required. In that due regard, standardization for the communication concerned to electrical equipment has been brought in by IEC, International Electrochemical Conversion Committee, 60870-5-101 or 104 mode of communication. The another communication protocol which was practiced was Distributed Network Protocol, DNP. Currently it is 3. This is designed specifically for SCADA. Now question comes. When this particular TCP IP is being used, why not this? This is for small center initially developed. Over the years of evolution of communication setup technologies, now the riding hand is TCP IP. Likewise, what was the DNP? DNP is basically defined for SCADA, Supervisory Control and Data Access System. It is Data Acquisition and Control Communication Protocol, exclusively for collecting the information. So end devices must be adhering this knowledge. The DNP compatible device, when I connect them one to one in my requirement, each is able to exchange the information on a query, on a request. So predominantly SCADA to RTU. You can see this. Predominantly DNP protocol is practiced at RTU to or IED to SCADA or RTU IED to communication. Between the, you can imagine how best it can think. Think a generating plant. There are 10 generators. Each generator is having its own automation around its generation setup. And there is one outside that generating plant, RTU is there. Remote Terminal Unit. That is what it compiles all the data of a generator in a plant, communicate it to the master terminal unit to be used in the energy control center communication. Then this RTU at the particular locality have electronic devices, intelligent electronic devices. How do this RTU get the data from the generator temperature sensor, generator P and Q measure, generator RPM. Then that RPM, that voltage, current, power flow, whatever is that has to be measured by some components. Those components are but intelligent electronic devices. They are the interfaces between physical component and electronic conversion. That communication with the RTU among peers should be distributed network protocol based exchange of data. This communication has to be there. You can imagine this kind of communication between the devices like RTU and IED or other way also. Next, that will communicate it to SCADA. So this way, this is being used. How it has evolved? Used in electric automation and prominent in the North and South America and Australia. Now, definitely, what I was communicating, how this communication and electronics evolution has come up, that has been used in the North and South America and Australia location. Later it has become, once you purchase the equipment of that particular mode or manufacturing, definitely this must be the inherit of that protocol to be interfaced in the electronic setup. If it is not, then I should not think of it. Then open standard, not owned or controlled by a single private organization. All vendors have a say in the design and specification. See, this is an open standard. Anybody can develop, anybody can manufacture adhering these syntax guidelines. Then not owned or controlled by single private person. So today I may manufacture a intelligent device for a certain guideline. I can sell in the market. And somebody X, Y, Z can develop its own electronic device adhering to this particular this. It becomes its own. So no single controlling authority is monitoring this. They just give a guideline. It's an open standard. Anybody can follow this, anybody can practice, develop, sell and purchase the component. So this is how it is being done in the initial stage of development of communications between them. So vendors, when they sell and when they go for service, they say there is something difficulty because everybody have their own perception of such component. Because in my design, someone else may have Y perception on me, which I have designed. In this regard, this is an open protocol. Anybody can contribute, anybody can develop, but adhere to the guidelines in this regard. Similarly, RT570 is another protocol used between RTU, remote terminal unit, in a substation and the front end. Just see, RT570 is a protocol. It is a language which the device-to-device data transfer takes place in a substation only. I am coming to a particular substation. There are so many components connected in the substation. Substation automation, when it is brought into reality, each device with a control panel and a measuring equipment and a display, they have to exchange the data so that that measured information is displayed and communicated further. So for those devices to communicate and get into interaction, the protocol, the communication channel which is resulted with the syntax RP570, the protocol. In nothing much, is the exchanging capability with those devices is within the operational purview of substation to equipment only. Then RP570 was developed by ABB. Okay, in the beginning of 1990, it was based on IEC 57. It is International Electrochemical Group number 57 Researcher, part 5.1. It is like a guideline. It is like a standardization guideline. Group number 57, TC, control group TC 57, developed this terminology of how equipment in the substation should respond to the SCADA or a computer in that group. What should be the way it query, in what format that should send the information, and in what format control signal should go to that device to act and implement it. In that way, the communication standards, terminologies and the width of data, all such things were defined in the standard RP570 for a zone, substation and equipment and front end only, not for substation beyond to the master unit, only within that. Presently known as IC. Presently, this is what RP570, originally developed by ABB in the early 1990, took its reshape, presently known as IEC 60870. This was the one we were discussing earlier. 60870. So known variants are RC571, EDLP80, EDLP180, like that. So it means this is the benchmark where standardization of communications between the electronic component and the substation automation of the electronic industry started. Otherwise, it will be very difficult. I will be doing my own, you will be doing your own, other will not be able to understand, other will get discouraged to purchase this because they don't understand. So you can see how the common protocols exchange among them become a bottleneck issue for the technological growth itself. Then field Profibus. So it is a Profibus. Devices communicate using standardized professional field bus DP, decentralized periphery. Communication profile, which defines the rule governing communication. The heart of communication profile is what is known as master-slave concept. Now see, the professional field bus system has come with a decentralization mode of communication. In a plant, suppose there is one master device signaling to all the peripherals with the master and slave. It will query slave number one, component number one, only one will respond. And it will query, only two will respond. It is a broadcasting. Information is put as a polling in the common channel. I want roll number 10. Only 10 will respond to me. Roll number 25 only are not all other. Like that, professional field bus kind of master-slave mode of communication in a system of communication or a field has been put into practice. Again, it has so many variants. And when the polling is done, polling has certain characteristics. Certain width of time, certain IO exchange, and alarm or fault, something should be sent. So this is how a professional field bus system is in reality. In the industry it is practiced. Group of sensors, group of devices connected to a master query timely at a particular duration. It will query all the status, it will collect, it will process. Again, it will some time stamp later, it will query, collect, process. In that way, it is a master-slave kind of approach. Again, when I see the next one, which is olden in the early 1979, Mod1. It is a Modicon in the USA developed this. So for their Xerox machines, their electronic devices, originally they developed a PLC, programmable logic controller. For that to device communication from component to component, they developed a language of communication for them as Modbus. Modicon developers in 1979 in USA made a serial communication between component to component, one-to-one serial. It is Modbus RTU. We developed. So like this, the main reason for this extensive use of Modbus over the other communication protocol are it is openly published and royalty free. This technology is open to public or open to manufacturers who can use this mode of exchange of data among the electronic devices. They can download this syntax of your communication down to the devices. Devices, after being configured, respect and communicate among each other in this Modbus periphery. Modbus allows for communication between many devices connected to the same network. For example, a system that measures temperature, humidity, communicates the results to a computer. Modbus is often used to connect a supervisory computer with a remote terminal unit. So we were speaking about the other part of the communication in a plant. When I bring the automation, the temperature monitoring, voltage measure, current, power, all those were individual functionalities with the equipment. Those equipments are connected to a central monitoring device like a supervisory control or a master. to which these end devices can communicate using Modbus. So this is the open protocol. You can define my component configured and automatically recognize Modbus. So this is how we use in the RTU only. The another olden days communication is Conitel. The Conitel is a protocol, is an asynchronous communication protocol used in many supervisory control and data acquisition systems. It is used in SCADA. So it is a message blocks are composed of 31 bit plus a message synchronization start bit. Means it is a flag to confirm start end messaging like that. So this is an message based Conitel protocol, which is an asynchronous mode of communication. Synchronous and asynchronous, like kind of asynchronous it receives. And this protocol may be used either in a point-to-point or a multi-point configuration. Now it's called as a point where a device which it want to connect to a neighbor second point, point-to-point, one-to-one directly, or single point to multiple point like this. So this is used in particular communication. It is either half or full duplex. Let us see this communication standard. So when I compare DNP, distributed network protocol, with a T101 or the particular mode of communication, I come back here, this one. The EC standard 608.70-5.101, intended for transport of data over serial link. So it is a question, compare them. Who developed this? DNP user group. Who developed T101? Is the International Electrochemical Team 57 Work Group 3. It is developed this. Standard of this DNP, distributed protocol, open industry specification. Anybody can contribute, anybody can use it. But IEC is not like that. It is governed, supervised, standardized by International Electrochemical Committee. That committee will not permit, authorize anybody other than what they adhere and register with them. Then dominant market for DNP is North America, and this is European countries. Then architecture, it is a 4-layer architecture, also supports 7-layer TCP/IP or UDP/IP protocol. The T101 is 3-layer EPA architecture. So these are the keywords from network terminology, from communication mode. For us, just we need to see how it is protocol by comparison. Main coverage, DNP will have application layer coverage. Then it is service and protocol like. The other also same thing, application layer, service and protocol only. Then device addressing, how devices are addressed. Link contain both source and destination addresses, both always are with a 16-bit in DNP. Then it is 32-bit address each data type per device, application layer, and does not contain address. So it is with respect to when I have a equipment purchased, which is to be installed in my controller or control area, which is responding for DNP, what kind of device addressing, how I should query it, how I should recognize it as my measuring element. It should be addressed. It's addressing its ability to respond. It should be queried or touched with a command. How do I address it? Link should be sent to that. It should contain source and data, source and destination address, both are 16-bit. Or application layer not contains address, does not contain addresses, which is of 32-bit point-to-point address, each data type per device. In other T101, link address could be 0, 1 or 2 byte. Here it is 16, 2 byte only. Here it can be 0, 1 or 2 byte. There is a freedom of sending the information for the devices. An unbalanced link contains slave address. So here both source and destination in DNP, but in T101 unbalanced, only contains slave. Whom respond? Who has to respond? That's all. T101 is saving the width of data communication. Then another is balanced link is point to point, so link address is optional. It is a point to point. Exactly. Roll number 10, only 10 will respond. 25. It is a direct connectivity between the element and the requirement. But it is not in the DNP. DNP, master slave broadcasting. It will broadcast, it will go to the destination. Only that component which is to be responding will respond in a sequential manner. But here it is point to point directly, only the destination point is identified. And parameter setting, control, cyclic transmission, open for other encoding solution are the other two comparisons what we can do. So this table is available in almost all the textbooks for the comparison of 5 to 6 parameters. This is usually asked. How you compare? This is exactly a network terminology. Communication network related terminology. Just we need to remember this for the point of comparison. Both are in service, both are in practice. The present era is T101 or 104.